Welcome to my channel. Your tutor Mariam is here. It's the 39th video of Introductory Physics 1, and the first video I'm going to talk about the laws of motion. That is the fifth subject of Introductory Physics 1. In this video I'm going to talk about the concept of force and what is the Newton's law. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So by definition, force is an interaction with an object cause any changes in the velocity of an object. I'm going to get back to this point of what it means by saying the change in velocity. But for now, let's think about it this way. If you pull the object, if you push it, even when you write something down, you are applying the force, right? You might have this question, what about if I sit down somewhere? For example, if my dog sit down on the ground, is it applying the force or not? Yes, because it's stay stationary, right? If there is no force there, then it looks like the object in the space, right? So it can move everywhere. In the space, there is no forces. However, on the earth, there is a gravitational force, right? So if I sit down somewhere, that means gravitational force applying on me, right? There are different kinds of forces, contact force and field force. We call it contact force when two objects has a physical contact to each other and they apply a force. One example can be a spring force. If I stretch the spring, I applying the force to the spring, right? So it's like I having the physical contact with that spring. Another example gonna be a resistance force. If I pull my carry-on, there is always a force doesn't let me to move the carry-on. We call it field force whenever two objects doesn't have a physical contact, but they are still applying the force. For example, gravitational force, right? When the ball falling down, or there is an electric force or magnetic force. For example, if we have two charges and one of them is positive, the other one negative, or they both can be positive or negative, right? So it's like they can be attract to each other or repel each other. Now let's talk about the first Newton's law. Object remains in the rest or move with a constant velocity if there is no force applied. Let me start with a common experiment. So I have a hockey table and there is a puck right here. If I don't apply a force to this puck, then puck gonna be there forever, right? Now let's say I apply a force this way, correct? Then we know puck start to move. But we know that puck gonna stop somewhere here, correct? So at this point, velocity gonna be 0. So what's happening here, there is another force in the other direction right here that we call it as a resistance force, and this resistance force causes this puck stop at some point, correct? I'm going to talk about this force in the next videos. But now think about it this way. I have this hockey table, right? And I have a puck right on top of the hockey table, but there is a little gap between the hockey table and the puck, right? So the reason I'm doing that because I'm gonna get rid of this resistance force right here, right? That's how experimentalists design the experiment to get rid of the resistance force. Now, if I apply the force at this point, this puck start moving forever unless I apply another force to change the direction or stop it. In reality, since we are living on the earth and there is always the gravitational force and resistance force, this puck gonna stop somewhere, right? But if you go to the space, there is no gravitational force, right? So if you apply a force to the object or leave it, it's gonna be there forever, right? Because there is no gravitational force. And if you would like to be more precise, there is still a force between the moon and sun, moon and earth, so it's still moving a little bit, but it's not as strong as the one we have on the earth, correct? This is a trick astronauts do when they launch a rocket. They turn off the engine so rocket can move forward with a constant velocity. The second Newton's law is about applying the force to the object, and this force is equal to the mass of the object times acceleration. So what you usually see is this equation, right? For example, if I have an object right here, if I apply a force in the y direction, I'm going to call it F1. I'm going to have another force, F2, the other force this way, F3, right? And the other one is F4. So my F here, my total F, gonna be equal to F1. I'm gonna put the vector on top, F2, F3, and F4. And you know that I can't simply add them together. It's just a notation that I'm saying F1 plus F2, right? And then this is gonna be equal to m, mass of the object, times acceleration. So what you usually see in the textbook is like this: F equal to m dv over dt, right? That's how we call it as an acceleration. The actual second Newton's law is F equal to ma, right? This is gonna be derivative of t m times v, right? So here we should also consider if the mass change with time, and also if velocity change with time, right? Sometimes mass also change, and we need to consider that. Most of the time what you see on your textbook is this equation, right? Especially for introductory physics 1. But it's good to know there is also another term right here. If your mass change respect to the time, right? Then you should also consider that. What about the third Newton's law? Let's say there are two objects, they interact each other, one apply force to the other one, there is no extra force, so that means the second object apply the same force with the same magnitude but opposite direction. So let's say I have the object right here, I'm going to call it as M1. There is another object right here, M2. Object 1 start to apply the force to object 2. I'm going to call it F12. So there must be another force in the opposite direction from mass 2. So, and it's going to be 2, 1. So let me get it clear. Let's say I have an object right here, M1, and there is another object, M2, right? If this object apply the force right here, it has nothing to do with object 2, right? The other example would be if I have an object M1 here and again M2 here. If object 1 apply the force to this direction, 1, 2, 2, the other force F21 can't be in this direction, or this direction. It must be with the same value, same magnitude, to the opposite direction, right? So it's going to be F21. I hope this video helped you to understand the subject and you like it. In the next video, I'm going to solve a couple of examples about it. If you like my video, hit the like button and I'll see you in the next video.